Okay, so if it's a 90, I'm gonna watch this marker right here. I'll stretch it up just a little bit. It's way up there at 90. So yes, it's going to touch, it's going to come up. Now it may not head directly to 90. It may go above it a little bit, then come back. Who knows? It's got to come back and pick up 2. Does it make sense? Now I took mine just a little bit above 90. I don't think it goes directly to 90. And it has a y-intercept at 90. Now at 2, here, understood to be what type of an exponent or the multiplicity was. I'm going to try to find 2 here. But the multiplicity of 1, which is odd. If it's odd, it should do what? Cross. So it's going to cross here, go down. I don't know how far down it's going to go. It's going to go down, and eventually it's got to come back and pick up 5. At 5, another odd, multiplicity of 1, and should cross at 5. It looks like it is crossing. So if I step back, that's a quick sketch of that original function up there. That's all we want right now, just a quick sketch. Does it make sense to follow all this? Okay, then we're pretty much done on that one. Now letter C, to sort of close this down. Before I leave, I'm getting letter C. I'm going to get a little sophisticated on you. The end behavior on these graphs. Let me go back. The end behavior, here we go guys. Let me go back to x cubed. Let's check out the left end, the right end, see what behavior is. So on the end behavior here, before I go any further, I'd like to know how's my graph behaving out on the left. I have a graph. I know what's happening on the left. It's falling. Is it? To the left of 0? And my red graph, if I say, how's it behaving to the right of 0? It is rising. Now I'm going to start using the notation from the calculus. They're talking about limits here. So here's the way it's written. You're asked to find the limit, and they abbreviate limit. They're like MIT, they abbreviate limit. As x is going toward negative infinity on the x-axis, x is approaching negative infinity. You're going to have this way forever. Of my function, and they want to know what is my function doing. As you go out to the left forever, x is approaching negative infinity. You're on the x-axis, you're walking this way forever to the left, negative infinity, and you look at your red graph. What's my red graph doing? Is it dropping down? As I pull it along with me, is it still dropping down? And that's described as it's dropping down through negative infinity. Now with the calc notation, which I think you guys need to see now, let's write the other end, limit. Now on the right of 0, we'll write this as what's x, or limit as x is approaching infinity. Out here on the right, positive infinity. So you're on the right of 0, you're taking that graph along with you, and I want to know what the function's doing, my graph is doing. And guys, please describe for me what is, and I walk this way forever on the x-axis. That's x is approaching positive infinity, and you're dragging that red graph along with you. What's my red graph doing? As I drag it along with me, is it rising through positive infinity? And there's your end behavior. Describe your calc notation. Since that's true, we jump back before I leave this one. Let me write the end behavior on this one we just finished up with the calc notation. Let's try to find first limit, abbreviation, as x is approaching negative infinity of this particular function. And all they want you to do is on the x-axis, go to the left forever, and drag the graph along with you. And anyone tell me what is that green part of the graph doing as I walk out this way? Is it rising through positive infinity? On the other end, like this, the limit as x is approaching positive infinity of this function. You guys and the x-axis is walking this way forever, way beyond 5. Keep walking this way, x is approaching infinity. And my green graph is being pulled along with me. What's it doing? Is it rising also? Another positive infinity. So that's the description of the end behavior with some limit notation. Now my last one, short one, a nice one here towards the stem. I'd like to graph this. No, here it is. P of x is this. Got a negative 2/3 up front. X squared, x subtract 2, x plus 2, nice. Negative 2/3 x squared, x minus 2, x plus 2. You know what? Guys, I'm gonna make it a little harder. Anyone say, maybe not. Okay, I'm gonna leave it. I like sketching. Guys, before I jump into the grid and try this, let's look at the zeros. Immediately, no problem. Zeros are, if you split this thing up, I see from this part right here, if you said x squared equal to 0, that factor tells me 0 is a 0. It's one of the answers. And I notice it came from a factor that has what, even exponent, so it's a multiplicity of 2 in this case. My next one, if I split this up to find another 0, no problem, we'll get a 2. I look back at the factor it came from on the outside, see a 1 there, I understood, odd. So this is a 0 of 2, multiplicity of 1. Up. And my last one, of course, was x plus 2, my last factor, solve it. So I'll get negative 2 here, and it looks like it's another multiplicity of 1. Let's close this up. Do we agree? Okay, now let's see what the graph may look like. In behavior, let's get that in behavior out of the way. Guys, we use my count notation. Let's examine first the limit as x is approaching, let's try a negative infinity on the left of this function. And we'll get an answer here shortly. And then I'll examine the end behavior on the other end, written like this, x is approaching positive infinity of p of x. That's a little more like a calc class. Now, all that depends upon what? What should I be looking at to answer the end behavior always? The first term. The very first term. Guys, this thing's not expanded out for me. And be very careful. Can anyone tell me what does the first term, if this thing were multiplied out, what does the first term look like? Okay, tell me the full expression. Negative what? It is going to be negative. But give me the full expression for the first term if this thing were multiplied, expanded out. Negative 2/3. X to the 4th. There you go. It's all one here. Negative 2/3 x to the 4th. Looks like I've been using that x to the 4th a lot here tonight. That's the first term. Now, here's what I would suggest. You see, Professor, here's the graph. I know what an x to the 4th graph looks like, Professor. I see an x to the 4th in the green up here. I know what an x to the 4th graph. But this one has a negative sign in front of it. Here's my x to the 4th graph. I don't like that negative sign. See, I'm just going to have it on the ends of this one. Is it going to be reflected through the x-axis? It's going to be upside down? with a negative sign stuck out front, reflection through the x-axis will be upside down. Also, I want you to think of in terms of limits now, also another way to find the answer is, let's make some sense of this limit notation from calculus. It says, please go to that green, that Michael did, and start replacing x by, I'm going to use the word large, but they're negative. In other words, you put a negative 10 in here. Negative 10 raised to the fourth is what? What is negative 10 raised to the fourth? It's going to be a positive? Like a positive 10,000? And you got to multiply it by negative 2/3. What would the final result be, positive or negative by the time you finish? You got a negative 2/3 times 10,000. I'm not going to actually get the value. What would that be though? Negative or positive? No. What would it be? This part can be positive, no matter what. You multiply by a negative 2/3 because the negative 2/3 plays a part here. Is the final result going to be negative? Now I tried negative 10. It says, right, this says, go further. Negative 100. Negative 1,000. Negative 1 million. I don't care what you put in here. Negative 1 million raised to the fourth, does it turn into a positive? Then times the negative 2/3 turns it into a what? Negative. All that tells me immediately this is, for the end behavior, negative infinity. Next one says, on the right, now replace x by positive big numbers. Right here. So start replacing x by positive real numbers, guys, like a positive 10, 10 to the fourth, and do your business. Put 100 in there, raise it to the fourth, do the business. What's the result this time? Is it negative again? So that tells me now what's happening on the ends of this graph even before I get to the graph. So the limits are negative infinity on both ends on this one. Now what does the graph look like? Let's see what it does look like here. Based on all this. You can't go wrong on this. Cannot go wrong. Okay guys, when you pick up those zeros, you got 0, 2, and negative 2. Those ends by here, and negative 2. These are my x-intercepts. If you'd like to find the y-intercept on this one's not interesting, the y-intercept is also 0. Now the end behavior, let me get that out of the way. Let's get the ends out of the way. Out on the left, this one right here says left behavior. It's dropping. The result is negative infinity. So it's dropping like this. Out here. Out on the right, described here, we got negative infinity again. It's dropping. That was the graph's done. Now at negative 2, which is one of the zeros, and negative 2 was identified as, like 5 here, a multiplicity of 1, up. So it should cross. Let me do it like this. As it crosses, how far up does it go? I don't know, but it's got to eventually come back and pick up 0. Now I'm at 0. 0 was also a 0 with a multiplicity of 2, even. What should happen there? It should bounce back or touch. Touch, bounce back. How high it goes, I don't know, you don't know, but it's got to come back and connect. Could that be a reasonable graph for the function? How high it goes up, how on this right here, there is a local max in there somewhere. I'm not going to worry about that here. And there's a local max somewhere in here. So we're going to go up higher than what I have mine, but I'll accept this graph as a rough sketch of this. Now, is all this making sense? How the rest could go wrong? You touch, you cross, the end behavior with that limit notation, that's no issue there. And it's graph, any graph I gave you to do. Are we okay with this? Okay. And that's one big chunk of that chapter 3 done. They're asking, can you graph one of these? Mr. Parker. Anna, I always refer to you guys. Math 7, Math 8. You guys graph these? You guys see graphs like these in Math 7 and Math 8? except now they're gonna do more calculus on those than we are here. Okay, so they will be able to, and I've said this many times, when you take that Math 7 course, you will be able to find exactly where that point is. Which I think is great. You will be able to find exactly where that local max is. I can't do it here in Math 2. Math 7 goes a little further, please. So you'll see these again. Guys, how's it look? So your professor started out with something simple, and then gradually led to something a little bit tougher, in behavior and all that business, but still involves something simple. Make sense? Okay. Now, I had a few students that show up at 4 o'clock. I don't know whether it's a Monday, and some students didn't show up. These weekends are killing us. I think we're gonna, Aaron, I think we're gonna finally have to start meeting on weekends. Mr. Park, Anna, yeah, we're gonna have to work out a weekend sometime, right? Get together and have a weekend. A little Math 2 social somewhere. Okay, because we're losing the track of all this. Now that said, here goes. To close this down and get into the part that the students who were with me at 4 o'clock were doing. If, this is beautiful, no problem here. If as I'm getting ready for this last part of this graphing, you may be sitting there thinking, now, Professor, when I finally leave SMC and I go to UCLA or USC or Columbia, Stanford, wherever you go, and I have to take a math course for some reason, I don't know why, I may have to take another math course, might I see this again in some version? You will. It's not going to change. So if they're talking about a max or a min, an increasing, decreasing, or whatever, that stays the same. No matter what level of math you're taking, or what school. I'm going to call this part 2, I think it is. You guys can remind me, I think it's part 2. Part 2. I'm going to get a sketch to you. And I brought in a fairly nice one to close this down. The sketch has been provided. Here goes. Nice. And it looks like this. On the grid, I have this. That's coming up. I have one there for you. Not. Something else to look at besides this. I see one here, but I want one more challenging. For this class. Yeah, here it is. The function looks like this, guys. It has a 0 at -2. 2. Three. Those are my zeros. The graph itself is going to look something like this. Going down, gets that 0, x-intercept, goes up, comes over, picks up that 0, it drops down, comes back up, picks up 2, it goes up, comes back down, picks up 3, touches, bounces back, out there. Looks something like that. Nice. And, look that, there's the graph, already done for you. And I did this for a reason. I said, hold on, I'm gonna give you one of the points. Out 1, down 4, what's this right here? I'll label that as a point that has been given to us for some reason. That point, out 1, down 4 is on that graph. For a reason. Now I'd like to write the function, the equation representing that graph. So what this is, p of x is equal to, let's try this. Now, let's start from left to right. Can anyone give me a start? I notice there's a 0 at -2 and I have it to touch. So what might that tell me to write immediately to at least represent what's happening here? X plus 2 squared. Now, Michael said square, I usually ask you to use the lowest. If a student says, Professor, can I write as x plus 2 raised to the 4th? Or x plus 2 raised to the 6th? As long as it's even. We usually choose the smallest even number. Makes sense of it. As I travel further, I see there's another 0 here, and 0. Now, how would you best represent the factor that gave me that 0? X, and does it touch or cross at that point? Crosses. Just plain X, X to the first, right, like that, with an odd X mark. Finally, I get to my next 0, 2, which I see crosses again. Best expressed as x minus 2 raised to the first. And then my last 0 is 3. Now notice when it touches 3, in fact it does just touch at 3, it bounces back. Best expressed as x minus 3. I would suggest you use maybe a 2 rather than a 4 or a 6. And make it look like that. Does that all represent what you see up here at this point? Now, I noticed, that's the reason I'm searching around here to find this particular problem here. I noticed this last one, to make a connection, there was a number out front, which there could be. In that case, it was -2/3. There could be a number out front, I'm called A. I don't have a number right now, except understood to be a 1. There might be a number out front like -2/3 was on that last one. I'd like to find, if I could, what particular number is this on this particular one? What do you think I'm doing now? Why did I give you that extra point? I think you guys did this for parabolas. Did you? You may have done this on an exam or a quiz already. Is that true? So if I gave you a point here, that says, oh, if that point is on that graph, Professor, that tells me at this point I can go in and replace y by -4 and x by 1 and make it look like this. -4 on this side, I've got a, and replace all the a's by 1. Not the a's, the x's by 1. And step back and make sure everything's put in there correctly. Replace all the x's by 1, the y is -4, and then we'll crunch this out. So I got -4, a, the only way you can miss this would be the arithmetic. I see this is a 9, looks like, 3 squared, of course 1, I'll just leave 1 out. 1 subtract 2 is a -1, On the end, looks like maybe a 4 after you square it. If there's no mistake, it's -4, it's equal to A. And guys, I think all of that is a -36. I think. Is that true? And then to solve for A, divide both sides by -36. If I do, it's going to look like this at this point. Try to solve for A. Let's cross out of course. Reduce that down to positive 1/9. And let's hope I have no mistake in the arithmetic. There's the A value. I hope it's not a mistake. That means now I can now go back and say, hold on, Professor, you make this look even better. I know what the coefficient out front is. It's 1/9. And there's the function that this graph represents. Now, could we do that if you saw this on a quiz? If the graphs are given to you, could you put the pieces together and write the function it came from? Okay, and easily done. And of course, there's many ways you can check this. And there's the graph, done. Now guys, I started class out with the easy part of chapter 3. The easy part is graphing. Who would think that graphing would be easier than what's coming up? This is the easy part coming up. Now, what's not so easy is, here we go. The graphing has been done. Now you guys were with me at 4 o'clock. And I got a handout to give you to sort of help us here. What on earth could be hard? Professor made the graphing look so easy. What could be hard on this? Moving to part 3. Here we go. Find the complex zeros of these polynomial functions. And I may, if we find them, I may graph it to tie in graphing this. Now I brought in so much today. I brought in for my first one, find the zeros. It look like this. Oh boy. Looks like I jumped right into it. Oh, I did. Here goes. I'd like to find the zeros for this function. P of x is equal to 2x cubed plus 11x squared, subtract 7x, subtract 6. Now, how many zeros am I expecting? 3. I use the word complex. So of those 3, there could be some with i's in them. I don't know yet. But I gotta come up with some method to find those 3 zeros of this polynomial function. Now, I asked my 4 o'clock session, and some of my students in the 4 o'clock session gave me some ideas of how would you first, as a clever student, search for those 3 zeros. Guys, let me ask now the class, what would you do if you saw this, no more detail, and you got to find 3 zeros? What would you do? Say, this is too much, I'm dropping out. Should we get? That's exactly the first thing I thought when I first saw this. Beautiful. Well, she tells me this, Professor, we usually do this. And it worked out so beautifully last week. It won't work out beautifully today, this one. That's the first thing I thought about, grouping. Grouping's not gonna work. So I gotta turn to something else. I gotta find those 3 zeros. Now, let me share with you on the side and lead you into where I want to go. Some students may know where I'm going. on the side here, since group is not gonna work, and I've got a nice little handout here for you. I need to point out, if I brought it in, sure it is, here we go. Looks like this. On the side, and we'll get back to this, if you were given, and I'll show you what I'm doing here, this polynomial function, this trinomial, set equals 0, and they ask you to find the zeros. Everyone in class, if there were a quiz problem, everyone in class would walk out with a 10 out of 10. If that was a quiz. Because here on this one, there's no grouping needed. This one takes me way back to middle school. It does this. It can be factored. And you split these up and write quickly. We've done this many times. X is 3, x is equal to a negative 2. I say, Professor, my goodness, it's negative 3, positive 3, and negative 2. You're done. Is that true? Now, a little story behind this, where I'm leading you, and then we're going to get back to this. A little story behind this. I used to, I think I mentioned this last one day, I used to be a supervisor of student teachers. So they'd send me out to the city where I was living, and I had to go out to various high schools, and I sat in the back. Some of you guys may have had a student teacher in class before. So my job was to sit in the back. I was representing the university where they came from. I sat in the back, and I had to observe the teachers teaching. And then I had to critique them and talk to them about what I observed in class. And whether it's discipline, some students were talking, they were out of control. The teacher was out of control. Some of my student teachers were out of control. Students were out of control, or the lessons did not go well, students didn't quite understand. And I stepped in, and I still remember this so clearly. The student teacher was teaching something like this. And I was sitting in the back, true story. And a guy, one of the students was sitting close to where I was back there. And she was talking about this factoring and all this business, and to get the answers like this problem here, and the students were following along. The students knew how to factor and get the answers. And all of a sudden the kid who was sitting next to me, I looked over at his paper, he had the answers. He had the answers. But I kept looking closer, and he did not factor. She was discussing factoring. She wanted her students to factor. That was the topic. And the factor, she wanted to see this, to get those answers. He got the answers, but did not factor. And that break, I went up to her and I talked to her. I said, one student said, "See next to me," I said, "He's not factoring." And she said, "Oh, Ramsey, he doesn't know how to factor. He's having difficulty factoring." I said, "Really?" But he got the answers. So I thought about it. And they came back from break. And she did continue with this. And he started still getting the same answers the class was doing, but he did not factor. He couldn't factor. Can anyone tell me what did he do, for example, on this one? What was that kid doing? Not factoring to get those answers. Clever. I commended him as to how he got those answers. Guess what he did?
Finding possible zeros?
Do it again.
Finding possible zeros?
Okay, close. Very close. Something else. And I thought, wow. I love what he was doing. But he was not doing it quite the way the teacher wanted it to be done. And then I changed something for him, and his little method messed up. But right now, what you see up here, his method worked. Yes, I saw a hand going up. Yes?
Is it like a remainder theorem?
well, we're not quite to remainder theorem, we're not into that yet. All this kid was doing, he was desperate. He wanted to get the answers. All he did, he went down to the constant term. Look at this, how clever. He went down to a -6, and he listed all the factors. What times what will give you -6? He listed all the pairs. He says 1 and -6. That's why I'm doing this. -1, +6. 2, -3. -2, +3. I think those are the only pairs you would list here in this case for -6. 1 and -6, -1, 6, 2, -3, -2, +3. Is that true? And you know what he did after he listed everything that multiplied together would give you -6 on that end for that constant term? He, and this is why it took so long, he took the effort to take each one of these and plug them in to see which would work. He plugged in 1 and got 1 squared, subtract 1, which is 1 subtract 1, 0. Then -6, which he saw would not work, did not give a 0. And he kept searching all these numbers until he found the one that when he plugged them in would give you a 0, would work. And finally he found those two to work. In fact, that 3, if I plug in 3, 3 squared is 9, 9 subtract 3, here's 6, 6 subtract 6, 0, and I saw a smile come on his face. He knew 3 had to work. And then he tested -2. If you replace x by -2, what's 4? This turns into a +2, 4 + 2 is 6, -6, 0. He had the answers, but had no idea to do this. Just could not do it. So she gave him more and more and more to do, and I watched him, and I started talking to him, and he started telling me how he was doing it. I said, wow, that is so clever, really clever. And he got the answers. Then she finally, before class ended, got to a problem something like this. Now, let me make up one real quickly, then I'll show you what I'm talking about. I'm just creating one right here real quickly. Yeah, say 6x squared plus 5x minus 4. I don't want you guys to see here what, but that's it. That looks like it might be good. Yes. So as I sat next to him, I thought, hold on now. I asked him, I said, now try your method on this one. Now you gotta keep in mind, this kid knew nothing about factoring. Okay. What do you do? He said, well, I'm gonna go down to the end, constant term they call it, and list the factors of -4. 1 and -4, -1, +4, 2 and a -2. I think those are the only factors of -4. Now, if we're patient, and he was patient, if it's working out, that's what he did on the first one, it worked out. And some others that she'd given. If I try one, guys, put in 1, I get 6 plus 5 is 11, 11 subtract 4 is not gonna work. For that, to get a 0. If you plug in a -4, it gets worse. Plug in a -1, I'll tell you that's not gonna work. None of those will work. His little system failed. That's what he was doing. He was just going to the end, pick up that constant term, list all the factors, and was very patient and tested each one of them until he found which one worked. And all of a sudden, none worked here. And he thought maybe the teacher was playing a joke or something, that maybe she gave something that would not work. And all of a sudden, the other students were saying, hold on, I think she was teaching this. I think, let's see if I can get this to work out for me. 2x and 3x, guys, I think it's going to be +4 here. Let me step back, -1 here. And that's what she was hoping to see. And it factors, and you split these up, you know how to do this. You're going to end up with 1/2, and you're going to end up with a -4/3. Now watch carefully, because it's leading me into where I want to go. Is that true? Those are the answers. That kid would never gotten those answers. He would have never gotten those answers. Those that came out aren't even in the choices he was doing. Now, see how much time I got here. Beautiful. About 5 minutes for a take break. Then I talked to him. I said, could you maybe modify this a little bit? And by the way, guys, what do you think's messing up his little technique on this particular problem? What did I do as I sat next to him? How did I throw him off? What messed him up? His little technique that he was using back here on this one would work. On this one, it doesn't work.
The leading coefficient?
That leading coefficient must be a what for his system to work? 1. So if that leading coefficient is a 1, you can use what the kid used. Just list the factors of that constant term, test them, you'll find the answers here. I threw in a leading coefficient of 6. His little system didn't work. So we talked it out, and I said, let's try to modify this little system then. Keep your choices. 1, -4, -1, +4, 2, -2. Keep those choices. But now, guess how we're going to have to modify it? That's 6 out front. Now notice I drew a line there. Now you're going to list beneath these the factors of that leading coefficient, 6, which are 1 and 6, -1, -6, 2 and 3, -2, -3. Now it's got 2 sets of numbers to work with. Then guess what he does? If we talked about it. He said, oh, I had to modify it because of that 6 up front. We did that, and you gotta keep in mind, guys, the answers are these. Aren't they? Here's the answers. As we look through, look at this. He said, wait now, when I place 1 over 2, and then I actually plug it in, plug in 1/2 back up here in what was given, it'll work. And then the other one was what? -4/3? That would be me, placing -4 over 3 in the green, -4 over 3 will work. He was patient. You take -4/3, I don't want to take -4/3 myself, but if you go back and plug it in, replace it here, it'll work. And therefore now he has the 2 answers. I had no idea how to factor. Makes use of that little process. Now, before we take a break, here we go. On the side here, and I'll give you a handout after the break. I'll hold on to it after. I'd like to take a look at one with you. We'll take a break here. To try to incorporate, without the handouts yet, something, here we go, that looks like this. Oh, you guys find the complex zeros? Did we finish this one up? Oh. Let's try the process on this one. Now your textbook, and I'll use the symbols they use, the letters. They call this, and I'll have a name to it on the handout when you get to it. They say, form P over Q. From a fraction, like the kid was doing. On top, list all the factors of the constant term, like he was doing. So all the factors of my constant term, in this case, all the factors for -6 are, yes, 1 and -6, -1, +6, 2, -3, -2, +3. I think I have all listed. The Q, like he did, now list all the factors of my leading coefficient. And my leading coefficient on this one was merely a 2, so the possibilities are 1 and 2. Those in a different color. 1 and 2, -1, -2. The truth. Now here's the issue. Big issue. We're hoping that when you start comparing a number on top to any of these numbers on the bottom, and then a number on top, all these numbers on the bottom, a number on top, you get all those combinations, that hopefully, among all those combinations is a 0. I'm hoping, at least 1 0. The other other two or three, maybe imaginary, 4. Guys, here goes. What are my possibilities? What are my possibilities for zeros, for answers, in other words? Here goes. Could be 1 over 1, talking about process. 1 over 2, 1 over a negative 1, 1 over a negative 2. That's the 1 on top. Now let's try a negative 6. It's negative 6 over 2, negative 6 over, or negative 6 over 1, then negative 6 over 2, negative 6 over a negative 1, negative 6 over a negative 2. Bear with me, we'll get the break here shortly here. Now to jump into and try negative 1. By the way, guys, look at negative 1. Do you think negative 1 will actually repeat what I did with the 1 earlier? If I go through and start doing the same thing, negative 1 over each one of those on the bottom, will it actually just finally eventually give me these again? How about the 6? You think it'll just repeat what I did earlier with the negative 6? So let's leave those out. Let's go down to a negative 3. Negative 3 over 1, possible answer. Negative 3 over 2, possible answer. Negative 3 over a negative 1, possible answer. And negative 3 over a negative 2, another possible answer. What's left? Got negative 3, got negative 2. And let's see if I list this out. List all these. I got negative 3, 2, let's try 2. I think I may have left 2 out. Okay, 2 over 1. 2 over 2, 2 over a negative 1, 2 over a negative 2. Please tell me, is that enough there to see the possibilities? I think I've listed all of them. If you actually could list all of them together, you'll find basically it's 6. Guys, I got, if I count correctly, 1, 2, 3, 4, what is that, 16? We got 16 possibilities? Now, out of those 16 possibilities, I'm hoping among those 16 is an answer, a 0 for this. And we're gonna take a break shortly here. Does anyone have, of those 16 possibilities, a number that you think will work, Professor? And in my few minutes I have before break, I'll test it. Now you say, of the 16, any one, just out of curiosity, I'm not going to ask for a rationale why you chose it, and I'll test it. Michael, what do you got in mind? 1. You think 1 works? That would be nice if it does. Okay, you said, Professor, try that. That's a 16. Try 1 over 1, 1. Okay, if I try it correctly, Michael, here goes. P of 1. Let's go back to the original, put a 1 in, and P is going to look at this. Think. True? Do the math. This is 2. This is 11. Subtract 7. Subtract 6. And I see 13 subtract 13, which is 0. I'm not going to ask Michael why he started out with the 1, just because 1 was listed first. I don't know. But it worked out. Now, let's take a break here. Anyone give me one more of the remaining 15? Or who knows, 1 may work again. It may be a multiple answer. We'll find out shortly. But does anyone have of the remaining 15 maybe another one that looks like it's enticing, that it may work? And I'll test it. 1 works.
Negative 6.
Tell me again.
Negative 6.
Negative 6. Rihanna, I'll tell you about negative 6 when you use those large numbers. They usually don't work. If I put a negative 6 in here, hey Mike, you know what? Hold on. The reason I said it didn't work because you got to cube it. Negative 6 times negative 6 times negative 6, right? So I'm thinking we'll stay away from that, even though it could work. Does anyone have another choice besides negative 6? of the remaining 15? Negative 1/2. Okay, this last one we'll do, we're gonna take a break. Oh my goodness, negative 1/2, now what's gonna happen? I see what I could do. Michael, if I put a negative 1/2 in here, I got a cube it. That's a negative 1/8 fractions, which is okay. We know it may work. Then you gotta put it in here, do your business here, do your business here, do your business here. Hope it works here. It may work. Yes?
I have a question about calculation. 2 plus 11 minus 9 minus 6.
That's a 7.
Oh, I see.
Minus 7. That's true, guys? Did it work? Yeah. You thought it was a 9.
It is on a 9 in the, oh, at the beginning.
In the beginning, it's a 7. Right? Okay. So Michael, I'm not saying, Brianna, I'm not saying negative 6 is not gonna work. Michael, I'm not saying negative 1/2 is not gonna work. It may work. But they wouldn't have another nice number besides negative 6 and a negative 1/2. That might work. And right now, at this point, it's just a guessing game. Go for it. Negative 2? Okay, try negative 2. P of a negative 2. And we'll take a break, finish this up, and get back to the break. P of a negative 2, here goes. Guys, 2 times negative 2 cubed plus 11 times a negative 2 squared, subtract 7, negative 2, subtract 6. No. This is a negative 8. Oh, we messed up here. That negative 8 times 2 does that negative 16. And it looks like my second term, a square, that's a 4, that's a 44. Do not let me mess up. Looks like a 14. And subtract 6. Okay, guys, check my math out of it real quickly. Is the math okay on this one? Will those numbers add up to a 0? No. So, Professor, where are the other 2 answers? Where are the 2 more? Yeah, 2 more. Where are the other 2, Professor? Michael said try 1, we left out there, 1 more. Where are the other 2 answers? And I'd be very frightened if the other 2 are imaginary, because those are not even listed. The other 2 could be imaginary. I don't think they are in this particular case. Guys, any guesses before we close down and take a break? If you're going to need a break here. We need 2 more answers. Okay, so I'm gonna leave this right here. Jump back into it after your 10-minute break. I'll do time there.